So here we have the first one for today. Paper 1 questions of the topic moment of force. A man holds a 100 Newton load. Okay, whatever the description is, we can already see in the diagram. So I refer to the diagram. And then the first part is, what is the vertical force F needed in the biceps? So here we have this one force that we need to calculate. We'll rotate it. This is your pivot, first of all. This elbow over here is your pivot. You can call it P. So this is your pivot. One of the force is force F, and that would rotate your arm anti-clockwise. So we can write A with it. 200 Newton. Around the pivot, it will rotate your arm clockwise. This one would also rotate clockwise. Okay, so we have pointed out the forces that would produce the rotation clockwise or anti-clockwise. So what do we do afterwards? Simple. We add the clockwise forces, we add their moments, and we add the anti-clockwise moments. So one of the anti-clockwise force was F. We don't know the value of it. Matter of fact, we need to find the value of F. What is the perpendicular distance of that force from the pivot? So this is your line of action of force, this is your pivot, and the distance between these two is 4 centimeter. So F times 4 equals, because there is no other force anti-clockwise, so write equals. What do we have clockwise? 20 newtons. So we write 20 here, times, what is the force? What is the perpendicular distance of that force from the pivot? 10. Plus, the other force clockwise is 100. So we write 100 here. And what is the perpendicular distance of that force from the pivot? It is 32. So times 32. Now use calculator from here, and the answer for this one would be 850 newtons. Matter of fact, we move on to the next one. Question number 81. A uniform beam is pivoted at P as shown. Okay, and I'm going to mark the important information. We need to make it in equilibrium. That means the clockwise moment of force should equal the counterclockwise moment of force about a certain point. And it is a uniform beam. It means the weight would be exactly through the midpoint. Whatever the midpoint is, that would be the point where the weight of the object passes from. So the weight would be exactly through the middle. It is 1 meter long. 0.6 plus 0.4, you get 1 meter. So from here till here we get 0.5 meters in total. This would be your 0.5 meters, and this is weight of the block, and that would be at 0.5 meters mark. So what do we need to find? At which point should a further weight of 20 Newton be attached to achieve equilibrium? So what we can do is we can find the resultant moment, and that would give us an idea where should we be adding the additional force to prevent that resultant moment. ठीक है, उसको indirectly हम calculate कर लेंगे. So what is the moment right now? 10 times 0.1 plus, that would also rotate anti-clockwise W, and the weight of the beam is 100 Newton. Okay, given in the question over here. So 100 times, sorry, the pivot is over here. This is your pivot. So 10 Newton times 0.6, because the force was 10 Newton, and the distance of that force from the pivot is 0.6. The second force that you have is W, and the distance of that force from the pivot. So W times, this is the distance of that force from the pivot. You see this whole distance from B to D is 0.5 meters, because the total length is 1 meter and weight is exactly through the middle because we have a uniform beam. So this one would be 0.5. You subtract 0.4 from there, you'll be left with this one, which is 0.1. So W times 0.1 equals, what is the force that we have on the other side? We have 20 Newton force. What is the perpendicular distance of that force from the pivot? 0.4. So 20 times 0.4. And instead of W, because we know the value of W, it is given in the question, so I'm going to write 100. So 10 times 0.6 would be 6. 100 times 0.1 would be 10. And 20 times 0.4, even if you do it on the calculator, it would be 8. So we have 16 on anti-clockwise side, and we have 8 on clockwise side. So that means this thing gives you an information. You have less clockwise moment. So you need to add the extra weight towards the right side of the pivot. Only then you're going to increase the clockwise moment. So we are left to choose between C and D because we need to increase the clockwise moment, and clockwise moment can only be increased if you add a force or weight over here or over here. So for clockwise, let's say I add the extra weight, which is 20 Newton. I add 20 Newton over here at this point. Okay, so 20 Newton added at this point, at the point C. So will that force be enough to produce extra 8 Newton meter torque or 8 Newton meter moment of force? This is the question that we need to figure out. And since this one distance is not given, you don't know exactly how far the point C is, but you see each segment is 0.1 meter. It's given at the start. Each segment is 0.1. This is also 0.1. This segment 0.1. So the uniform rod is made up of different segments, and each segment is 0.1. So the distance between the pivot and C and point C would also be 0.1 meters. So I'm adding a force of 20 Newton clockwise at the point C, which is 0.1 meters away. So 20 times 0.1. 20 times 0.1. This would result only an extra moment of 2 Newton meter. And you can't have 10 plus 2 equals to 16. No, you still need to ensure that the clockwise moment of force is also 16. If you add the force over here at the point C, you get extra 2 Newton meter, but that is not enough to achieve equilibrium because you're still deficit by 6 Newton meter. So instead, I'm going to add this force, 20 Newton force, at this point, the last point, point D, 20 Newton. So if I add the extra force here, extra weight over here, 20 Newton, how much moment of force am I going to get? It would be 20 times the perpendicular distance of that force from the pivot, which would be 0.4. And 20 times 0.4, you hit it on the calculator, you get 8 Newton meter. So clockwise, now you'll be getting an extra 8 Newton meter, and this is the only possible way in which you have clockwise moment getting equal to the anti-clockwise moment. So you need to add the extra force at the point D. Only then the clockwise moment also becomes 16 Newton meter. Otherwise, your anti-clockwise moment is always going to be greater than clockwise moment, and your system can never be in equilibrium. So we need to add the extra force at the point D. Hence, the total moment of force clockwise also becomes 8 plus 8, which is 16. And for this one, let's skip through the description and we can have a look at the diagram. What is the minimum force F applied to each end of the lever that could lift the weight? So you'll be able to lift the weight only if the moment of force clockwise equals the moment of force counterclockwise. Okay, this is the main concept here, the same one in simple words. See, the string is coming from the front side. So if your weight 900 weight Newton weight is being pulled downward, so the string would move forward from this side and that would rotate your disc anti-clockwise. So this force is responsible for anti-clockwise moment. Okay, just try to visualize it. Your string is being pulled downward, so your disc would rotate in this direction like this, anti-clockwise. And the moment that you're applying through the lever, just visualize this direction. This is your clockwise moment. The direction of the forces tells you that the moment that you will be applying would be clockwise. So we apply the same rule once again. What we have is clockwise moment of force equals the counterclockwise moment of force. So what do we have for clockwise? Is these two forces, and whenever you have two forces equal in magnitude and opposite in direction, you can always you can calculate the moment by the formula of couple. So the moment in that case would be equal to the couple of these two forces. So how do we find couple? We multiply one of the force by the perpendicular distance between them, which is 1.20. So that is the total moment clockwise. Let's find out what is the total moment anti-clockwise. So you have a force, how much? 900 Newton. Okay, so this is the force 900 Newton. You can write the same force over here as well, 900 Newton times, what is the perpendicular distance of that force from the pivot? So pivot is your this thing over here, and the perpendicular distance of that force would be 0.20 meters, because this is the distance of the string from the fixed point. So you write 0.20 over here. The other important thing is all the answers in this question are given in Newton meter. So whenever we are writing the distance, we'll be converting the distance into meters. So for the weight, we have W times, which is 2.0. W times the distance of that force from the pivot is from 50 to 60 would be 10 centimeter, and 10 centimeter means 0.1 meter. And that equals, the other force is 4 Newton. And the distance of that force from the pivot is 60 to 100. How much is that? 40 centimeters. And in this one, it would be 0.4 meters in meters. So 2 times 0.1 would be 0.2. And then you have 4 times 0.4 would be 1.6. Then you can subtract the greater value from the smaller value to find the resultant moment. Question number 84. So the diagram is given. Which of the following describes the resultant force and the resultant torque on the object? Is the resultant force 0? The resultant force is not 0, or is it? This is what we need to find. So you see, you have a force of 45 upward, 45 downward. So that means the vertical force is 0. But how about the horizontal forces? What is the net horizontal force? That is 60 Newton towards right. So the sum of the forces, the net force is not 0. You have a resultant force, although the vertical forces are 0, but you have a horizontal net force which is 30 Newton towards the, 60 Newton towards the right side. So the resultant of the forces is not 0. So C and D, they thrown out the window straight away. Then we need to find if the moment of force, resultant moment of force is 0. Well, this one, 45 Newton here. Let's say this is your pivot. Okay, this is your pivot for 45 Newton force. So this one will rotate it clockwise. The lower one would also rotate it clockwise. So these two moments cannot cancel out each other. Matter of fact, these two forces would form a couple, and couple would rotate the object. It tends to rotate the object. So the resultant torque cannot be 0. The resultant torque by these two forces might be 0, or it would be 0, because let's say this is your pivot now. The moment of this force would be 30 times the perpendicular distance, whatever the perpendicular distance, let's call it r, the radius. So it would be 30 r clockwise. But for the 30 Newton downward force, not directly downward, but the one on the lower side. So for this 30 Newton force, the resultant moment would be 30 r and that would be anti-clockwise. So these two would cancel out each other. You don't have any moment of force produced by these two forces because they cross out each other. But the 45 Newton force, that is responsible for having a non-zero resultant, because that would form a couple. If I break it down further, if this is your pivot, this is your radius, and this is your radius. So for the 45 Newton force, how much moment do you get? You get 45 times the perpendicular distance, which is r in this case, and that would be clockwise. And what about the lower force? That would also rotate it clockwise. So you get 40 times r, but clockwise. So you get a total moment of 90 times whatever the perpendicular distance is. We call it radius here, clockwise. So your disk or the circular object would tend to rotate clockwise because it has a resultant clockwise moment. And the only possible way, or one of the possible way by which you would not be having any moment, is if they have not given you this force 45 Newton downward, rather this force is over here 45 Newton, but in this direction. The other important thing is all the answers in this question are given in Newton meter. So whenever we are writing the distance, we'll be converting the distance into meters. So for the weight, we have W times, which is 2.0. W times the distance of that force from the pivot is from 50 to 60 would be 10 centimeter, and 10 centimeter means 0.1 meter. And that equals, the other force is 4 Newton, and the distance of that force from the pivot is 60 to 100. How much is that? 40 Newton, 40 centimeters, and in this one it would be 0.4 meters in meters. So 2 times 0.1 would be 0.2, and then you have 4 times 0.4 would be 1.6. Then you can subtract the greater value from the smaller value to find the resultant moment. Okay, let's take a look at the next one. The beam is uniform means you get the center of weight exactly at the middle point, and all of the you see in this question the weights are not given, the forces are not given, rather the masses are given. So you can apply the principle of moment in terms of the mass. That would be the same thing. So let's do it this way: clockwise, sorry, anti-clockwise, anti-clockwise, and this one clockwise, because consider this thing as your pivot. Now let us apply the formula. So what do we get? We get 3 times this mass times the perpendicular distance of that mass from the pivot, which is from here till here. And how much is that? 0.35. Okay, given in the diagram itself. Plus the weight, center of beam of mass 1.4. So 1.4 times the perpendicular distance of this from the pivot. It would be this much. How do we find this thing? Well, the thing is, it is a uniform beam, and the total length of the beam is 0.40 plus 0.20. The total length of the beam is this much, which is 0.60. So the total length of the beam is 0.60. Okay, it's given in the question itself. So from the total length of 0.60, your center of beam would be at a point 0.3 meters or 0.30 meters. Out of the total length, the center of mass would be exactly at the midpoint, which is 0.30 meters. So this length is 0.30, but you need to find the distance of this force from the pivot. So what you do in that case is, if out of the length 0.30, if you subtract this thing, think about it, if you subtract the distance on the right side of the pivot, if you subtract this much portion, which is 0.20, then you'll be left with this distance. So what I'm going to do is, I'm going to do 0.30, which is the total distance on the right side of the pivot from the center, and I subtract this distance, which is 0.20. Then I get the distance, this one, between the force and the pivot, which would be 0.10. So 1.4 times 0.10, and that is all from the anti-clockwise side, and that equals to, what do we have from the clockwise side? 6.0 times the perpendicular distance of that force. It is given directly, this much, 0.15. So times 0.15. So there would be a resultant moment on one side. The moment of force would be more, but if you apply the same moment of force on the other side, then we can maintain the equilibrium. So let's see what do we have on the left side, which is the anti-clockwise side. So 3 times 0.35 plus 1.4 times 0.10. So the total that I get on the left side is 1.19 equals let's see what do we get on the right side. 6 times 0.15. So I get 0.9 on the right side. So let's subtract the smaller value from the larger value. 1.19 minus 0.9, we get 0.29. You use the masses for this situation. So the final answer that you're getting in this case would be kilogram times meter. The last step is very important because you did not convert any of the masses into force. In order to convert the mass into force, you need to use the formula W equals to mg. So your weight is a force, and that is a product of your mass, whatever your mass is, times 9.81. Mass, product of mass and gravitational field strength, or acceleration of free fall. So we converted our formula in terms of the masses, and the final answer, the resultant, was 0.29, but with the unit of kilogram meter, because this is kilogram, this is meter, this is kilogram, this is meter, this is kilogram, this is meter. Now we can convert the kilogram into Newton. How do? We multiply this thing 0.29 by the value of g, which is 9.81, and it would be converted from kilogram to Newton and the meter as it is. So your kilogram is now being converted into Newton. So what do is 0.29 times 9.81. So you get 2.8449 into SFs. It would be 2.8 Newton meter. So for this question, option D is the right answer. What is the other way that you can do this question? The other way would have been all the masses. Before you use the formula moment of force, convert all the masses into weight. Directly convert all the masses into weight. But I do prefer that one, because for that one you need to first convert all the masses into weight. So it would be easy if you can solve it for the value of mass first, and then just convert it. At the end you can only convert it into weight.